Hi, everyone, and welcome to our webinar. This is Tracy Berardi speaking, Program Director of CISQ, the Consortium for Information and Software Quality. Earlier this month, CISQ released a new research report called The Cost of Poor Software Quality in the U.S., a 2020 report. And today we're going to share research findings and recommendations from the report. So speaking today is Herb Krasner, author of the report. Herb is on CISQ's advisory board, and he taught software engineering at the University of Texas at Austin. Joe Jarzombek from Synopsys is a major contributor to the software assurance community, including CISQ. And he was at the U.S. Department of Homeland Security for many years on supply chain risk management. And Joe will be talking about or sharing some recommendations for improving quality in your organization. And Dr. Bill Curtis, Executive Director of CISQ, he leads our consortium and helps us to develop industry standards for measuring and managing software quality. Dr. Curtis is also the American lead on the ISO 25000 series of standards and Chief Scientist at CAS Software. So we published this report a few weeks ago on January 6th. And if you can believe it, next week is February. So over these last few weeks, the paper has been downloaded a little over 400 times, close to 2,000 page views, and a bunch of media mentions. This is actually the second edition of this report. We published it first in 2018, and then Herb took on a project of updating for 2020. With support from our underwriters, Synopsys, OverOps, and Undo. So you can download this paper if you haven't already. I think a lot of folks have, but there's a link in the chat box. Also, the link is up here on the slides, so you can go and take a copy of that. Our agenda for today, we'll cover the full hour. We'll start, Herb will begin with a summary of the report findings. Joe will provide a series of really good recommendations, and then Dr. Curtis will talk about our role in developing standards for trustworthy software to address a lot of these issues. And we're saving about 15 minutes at the end for Q&A. We have a couple of polls queued up, but you can enter your questions anytime in the questions box, and I'll help to moderate that at the end. So I'm going to give control now to Herb. Herb, thanks for all your great work, excuse me, researching this report and joining us today to give us some highlights. Over to you.
Okay, hopefully you can see on your screen. Let's see, I want to share my PowerPoint slides with you. There we go. Hopefully you can all see the elephant in front of you. I'm hopeful.
Perfect. Yep.
Okay. Welcome everybody from the Hill Country west of Austin, Texas. Beautiful day here. Hope you're doing fine, staying well and safe. Thank you for joining me to hear about this elephant that I'm going to talk about. And my quest is sort of like the parable of the elephant and the blind men, except that what we're looking for is to estimate the weight of the elephant. And so I'm going to talk primarily about the cost aspects of the report and just hit the broad recommendations. The details are certainly in the report if you want to look them up, and so I'm just going to go through those real quick. First of all, I have a few people to thank. So thanks to our sponsors and supporters. Tracy already mentioned them. They help sponsor this work. Also, thanks to my review team, who are all mentioned here, among them the people that are on this webinar. So thanks to you all. During the presentation, I'm going to make reference to a few abbreviations, which are typically standard, but there they are, just so that you know when you see them. Okay, and if you don't know what a function point is, I'll try to get to that when I cover that. Okay, so let me present introduction. So our purpose in tackling this report was basically to inform and inspire those of you out there to seek this kind of knowledge within your own organizations. And so we made the assumption going in that most of your organizations do not collect and report this kind of data currently. And I'm guessing that if I ask that question now to the 61 of you that are on the webinar, we might get an interesting percentage back out of that. So that's the working assumption. So you might say to yourself, well, if nobody collects this data, then how did you come up with an estimate? So the methodology of the report was basically using 88 existing sources of available online information. All of these 88 sources are hyperlinked in the report, so you can see them all. And what they represent are different perspectives and viewpoints on the issues of software quality and the cost of quality. And I did my best to analyze those and synthesize those, extrapolate from those, making a few assumptions where I had to, and a few extrapolations, but basically to come up, with some kind of an approximation of how big this elephant is. So what you can think of this as a first order approximation of the magnitude of this huge and somewhat unrecognized problem, at least from a cost perspective. So that's basically what the report's all about. And at the end, I'll be glad to entertain additional questions about the details of all this. Okay, so one of the things to be aware of that we used in the first report and we refer to here is what we call the iceberg model of the cost of poor software quality. And in that iceberg model, we typically find a number of direct observable costs that are typically seen. So especially when a software failure results in death or lawsuits or whatever, those costs are typically observable. But then there's all these costs that are typically hidden underneath the water of the iceberg model, and such things as fixing bugs and overtime and technical debt. And the interesting thing is, in general, these hidden costs are 60 to 50 times the amount of the observable costs. So there's a lot of stuff that we don't see, and that's kind of what we're trying to make visible in this report. So let me hit the highlights of the actual cost estimates, and just to give you some basis for comparison of the magnitude of these numbers, if we take a look at just the U.S. gross domestic product for last year, the best estimates at this point are it's going to be around $20 trillion. That's down a little bit from the year before, probably because of the pandemic. So that's one number to think about. Another one is the actual total amount for the U.S. IT labor base, which I estimated to be about $1.4 trillion. Now that number came from some data that I found at the Bureau of Labor Statistics, and I had to adjust it, because it didn't include things like the C-suite executives like the CIO and the CTO, and it also didn't include the gig economy laborers who were doing software development. So after a little bit of adjustment, I was able to come up with that approximation of what our total labor base is in the U.S. for last year. Okay, so here's the big number. The total cost of poor software quality in the United States for last year, 2020, is $2.08 trillion. Okay, so we compare that to the GDP. It's about 10% of GDP. Compare it to the labor base. It's twice as much as the total labor base. So you say, well, gee, that's a big number. Yeah, that's the idea. And so I broke that down into some major categories, which are outlined in the report. But if you just look at the cost of operational software failures, that came out to about $1.56 trillion. Okay, one of the largest segments of that and largest growing segment of that has to do with cybersecurity failures, including data breaches. And I'll talk more about that later in this discussion, and Joe will also elaborate on that later. Okay. We also identified what was the cost of maintaining legacy systems, and that turned out to be about $520 billion. We looked at the typically unseen costs of unsuccessful development projects, those which are never delivered. Okay, and that turns out to be about $260 billion for the year 2020. And underlying most of those categories is this other interesting phenomena that we took a look at, and that is, the cost of finding and fixing defects in the software, which spans all of these categories really. And we estimated that to be about, by itself, about $607 billion for last year. So still some big numbers. We also took a shot at estimating the amount of software technical debt that was out there. And technical debt it isn't really a part of the cost from last year because it's a future cost. So we don't include it in the cost of poor software quality, other than to let you kind of get an idea of what you can expect in the future as this technical debt grows over time. So those were the big categories, and those were the big numbers. All right, so I'm going to go through each of those categories and try to hit the highlights. All right, so operational failures. Okay, you just watch the news reports, and the really big failures, amazingly enough, pop up in the news. And sometimes they pop up with numbers. Okay, and sometimes they're multi-year phenomena. So like the Equifax data breach, which happened in 2017, they're still paying on that. Okay, so we saw that one pop up, and then of course the most recent one that we're seeing, is the SolarWinds hack, and that one just keeps going and going and going. Who knows what it'll end up costing us. So one of the sources of interesting information on operational failures was a report that used to be done by a company called Tricentis. And the last one of these, they called it the Tricentis Software Fail Watch, 5th edition. And they collected data from news stories, English language news stories, on 606 major software failures from 2017. All right, and they totaled that up, and then they averaged it. Okay, and it turned out that the average cost of one of these software failures was about 2.8 billion per failure. So a pretty big number. This is one of these areas where if the failure is big enough and it costs and it hurts enough, it will be reported, and we will find out some more information about it. So in the report, I actually did cite some case studies on that for last year. Okay, why are these things happening? Well, they're happening because of flaws in the software. And what we're seeing, in the industry is that certain trends that are happening are magnifying the impact of these software flaws, driving the failure costs up. So for example, if you just look at the amount of new code that's being produced, okay, we estimated a little over 100 billion new lines of code being produced worldwide each year. And we know from previous studies that on average, 25 bugs per 1,000 lines of code are being injected by the software developers. Okay, so that basically tells you, just looking at that, how many bugs are being introduced and how many software flaws and there are in all the new code being developed. If you're looking at data breaches and data exposures, we now have something like 96 zettabytes of digital data stored, which is up from 16 zettabytes in 2016. Down on the bottom, you'll see that a zettabyte, if you didn't know, is equal to 1 trillion gigabytes. So we got a lot of data online, and a lot of it is exposed. And that leads to the next line: cybercrime. Ransomware alone, from what we know at this point, is costing us about $9 billion in the U.S. That's probably a low figure, given what's happened lately with healthcare systems and the government hacks. So cybercrime growing, ransomware in particular. Increasing digital transformation is happening. In fact, a lot of companies are speeding up their digital transformation efforts because they needed to, because their entire workforce went remote. So a lot of that going on. The complexity of systems. We have a lot of systems which are now built on top of systems, which are built on top of platforms, which are built on top of other technology. And that kind of growth of systems is creating this complexity that's hiding the triggers of these failures. Increased competition. When you prioritize speed to business over operational risk and corrective maintenance costs, what you're doing is you're taking a gamble, especially if these systems are not being designed to expect and manage failures. So all those things are the major causes of these failures. Our basic recommendations in the report were these things: prevent the bugs if you can, prevent the flaws, weaknesses, vulnerabilities. If they're not being created, then they won't be fielded. If you can't do that, find and fix the bugs early, measure quality, adopt high quality development practices, and for goodness sake, analyze potentially flawed components, especially open source software packages, where people are making a lot of assumptions about how good the open source components are, and rather than in fact analyzing how good they are. Okay, so cybercrime, we talked about the fact that area is increasing. So here's a little infographic from Embroker that basically shows that how cybercrime costs are growing, expected to be $6 trillion annually by 2021. Okay, quite a bit of growth in this area, and then that's worldwide. Here in the United States, you can look and see what the FBI Internet Crime Complaint Center has been tracking in terms of total complaints and the total losses of those complaints. And you can see the trend graph yourself. Okay, so the trend is going up in terms of losses, is going up rather quickly, and that's worth worrying about. I will leave it to Joe. We'll talk some more about this. This is cybersecurity is really his area of expertise more than it is mine. So I'm sure he will elaborate on this area. Let's turn to the area of unsuccessful projects. Those projects that tend not to ever see the light of day in terms of operational capability. So this information comes primarily from the chaos reports that have been going on now for quite a while. And we're going to look at projects in 3 categories: failed, successful, and challenged. And I'll tell you a little bit more about it as we look at the trends, but let's look at failed projects first. Okay, so they've been pretty steady over the last 16, 20 years at about 19%. Now, what that means, failed projects are the ones that are canceled. Okay, so they never see the light of day. And so 20% of the projects in our country are failing according to those criteria. Okay, the ones that are successful, and by successful, what we mean here is they're delivering on time, on budget, and up to quality expectations of their customers. Okay, and that category, is around 35% of all projects, and that's, as you can see, that's gone up a bit and it's kind of stabilized. Okay, the challenged projects are the ones in between. These are the ones that are late and over budget and having quality problems and are stuck in testing, and testing keeps going on and they can't release it, and yada yada yada. And you can see that the percentage of these kinds of projects are close to 45% of all projects. So when you add all that up, what you're looking at here is $260 billion of basically wasted resources. Okay, the goal would be to reduce these unsuccessful projects. So I'll show you a couple of quick data points. If we make the assumption, if you don't know what a function point is, just assume it's about 100 lines of code. Okay, so the larger the project, the more likely it is to be canceled. And here's some data from Jones and Basigner, their book. And basically what it shows is that projects of a certain size are more likely to fail if they're of low quality than they are if of high quality. All right, and so that's what the X factor is in the rightmost column. For example, those projects which are 10 to the 5th function points, okay, are 5.4 more times likely to fail if they're low quality versus high quality. Okay, so that's basically what this table is telling you, and that's what we're seeing. And so the basic recommendations, if you want to reduce the number of unsuccessful projects, from our perspective, is you should define what quality means for each specific project, and then focus on achieving measurable results against stated quality objectives. Okay, use known best practices and tools. Don't compromise quality for speed to operation. As it turns out, those projects that are challenged and are late are normally due to low quality problems because all the bugs that are introduced have to be tested, and it stretches the schedule out and so on and so forth. So quality is a major issue in the number of unsuccessful projects. Okay, legacy systems. I won't spend a lot of time on this, but you all know what legacy systems are. People always ask me, do I know COBOL? Yeah, I used to teach it. Okay, and so the problem with legacy systems is they get brittle, and the longer they're around, the more difficult they are to support, and for a variety of reasons. Typically loss of knowledge, increased complexity, loss of vendor support. Okay, and it's a big piece of the IT budget. Okay, and so it's worth thinking about, well, what can we do for these legacy systems? Okay, and this is a difficult area because it depends what you're trying to accomplish. So there's lots of strategies that you can use to try and attack the cost of poor quality software in this area. All these strategies are essentially enabled by overcoming the lack of understanding and knowledge of how the system works. So any tools which help you identify vulnerabilities, weaknesses, flaws, et cetera, are going to be useful. Recommend benchmarking as a place to start. Okay, the other area which is hidden is the area of finding and fixing bugs in general. And at $607 billion, there's a pretty big opportunity to fix this or to enhance this process of finding and fixing bugs that I'm showing you now. If you stop and ask the question, where's all the money being spent? It's in these areas. So the whole idea would be to prevent these bugs from happening, but if you can't, then focus on where the money is being spent if you're going to reduce the cost of poor quality. Okay, technical debt, I'm going to skip over really because this is a nuanced topic that I could probably spend the whole time talking on, and I'm already running late. So let's just let you know that where technical debt comes from is the existing code base, which is about 1.655 trillion lines of code worldwide, and about 513 billion lines of code in the US alone, growing at about 100 billion lines per year. All right, so we're going to skip over that because I really want to show you this interesting data to give you an idea of what's possible if you focus on quality. So this is an unknown study, relatively unknown study, that IBM did back in the 90s of 363 European software organizations, looking at the performance factors that I'm going to show you. These performance factors: productivity, delivered quality, cost and schedule performance, all right, and post-delivery maintenance costs. And they took a look at the difference between the top 10% of these 363 organizations and the bottom 10%. So if you look at the top 10%, they were delivering 25 function points per month with a delivered quality level of greater than 95% of all the defects removed, and getting within 10% of the original cost and schedule estimates, and their post-delivery maintenance costs were less than 1% of the total development effort. All right, contrast that to the bottom 10%. Look at that. Okay, look at that striking difference. And then when IBM asked the question, well, what's the difference between the top 10% and the bottom 10% in terms of what practices they were using, we found this out. Okay, and I'll just ask you to focus on this area up here, all right, where these were the major best practices being used in those organizations in the top 10%, all right, that were achieving both cost and schedule performance and quality performance. Okay, enough said. All right, so in summary, the broad recommendations, at the C-suite level were to establish quality as a first-class citizen, ask better questions, and I put some of those questions in the report, and measure quality and the cost of quality in your organization. For teams and projects, strive for high performance, use best practices and tools, define and track quality objectives, avoid arbitrary and unrealistic schedules or constraints. And for individuals, learn and grow, don't be afraid of metrics, use existing knowledge sources of bug pattern and structural quality flaws. Okay, and we rolled all that into the idea of pursuing, a new model of development called DevQualOps. And it sort of looks like DevSecOps, but basically what we've added is the idea of continuous quality engineering with specific quality engineering gates between the major phases between agile development and continuous delivery. Okay, and do not release decisions. Okay, so that brings me to the end of my talk. Thank you for your attention, and I will entertain other questions at the end. Okay, so I want to give the presentation.
Thanks,
Tracy, can you take it away from me?
Yeah.
Yep.
Okay.
Yep, I'm going to take this back.
Take it away, and thank you all for your attention.
Thanks, Herb.
Nice job. Thank you.
As you're setting that up, I have to say that we have a lot in common. First of all, you have to understand all three presenters today are in Texas. And Herb and I both have our roots with the University of Texas, since I received both of my undergraduate degrees at the University of Texas, both in computer science and the other in business with data processing and MIS. And I will tell you, it was there where I started thinking about this whole notion of quality and security in particular, as I went on for my master's work and focusing more on quality, but still keeping security in mind as part of that. And things that we're going to be talking about, you can go to the next slide, that while I was in the Department of Defense and later in the Department of Homeland Security, I was now sponsoring these enumerations of weaknesses as well as vulnerabilities. And many of you are familiar with CVEs, the common vulnerabilities and exposures. And it was as a result of that, we understood that today, while there's over 148,000 known publicly reported vulnerabilities, there still remain fewer than 1,500 weaknesses. These are the root causes that if you don't mitigate them, they will eventually result in numerous vulnerabilities from those same ones. So you heard Herb saying, calling out weaknesses and vulnerabilities. And I will tell you, the vast majority of people think they're one and the same. There's certainly a relationship, but they're different. And that's why this is actually a model that I generated when I was in the Department of Homeland Security that says, all of these are classes of weaknesses. It's really only when an exploit is designed to take advantage of a weakness or multiple weaknesses to achieve a negative technical impact is what makes that weakness a vulnerability. And since we generate these CVEs, and you hear a lot about zero-day vulnerabilities, and we're talking about the bad guys, how we're a victim of that bad guy coming after us, and yet we don't fundamentally understand the fact that they simply took advantage of weaknesses that were in our systems, and they did it, and they were more committed to finding them than we were. That's the challenge we have. And when we talk about technical debt, weaknesses are a form of technical debt. It's just a matter of when you work them off, not if, because as long as they exist in that, these basically represent those source vectors for somebody to exploit the systems. So we want to be able to address software failures by addressing and focusing on the mitigation of weaknesses as well as the better known CVEs. We want to address security as part of quality defect prevention. And we want to be able to automate quality in our workflows by using tools with security domain checkers under the hood. The challenge is we hear from industry that says we don't have enough security experts. What we need to do is arm all of our developers with tools that have that security domain checkers under the hood so that they can just treat normal security flaws as part of quality flaws. And in fact, if you look at the ISO standards, 25000 series, security is a part of quality. By ISO standards, it's already there, but we too often see separation within organizations. Quality is treated by the development team. We have QA team, they'll do, and a separate group for doing security. We need to be able to bring that together if we're truly going to make a difference here. So one of the recommendations you're going to see at the end is recommending that you leverage the use of the automated source code quality measures that are 100% based on CWEs to now include data protection. We want to be able to do that to understand our risk exposures while we're in development. Don't wait until it's actually been exploited. We want to be able to shift left to address quality early in the life cycle. You want to be able to enable developers to address this, not when they do code check-in, not after they release the code, but right when they're at their desktop to be able to do that. And understand that both CWE and CVEs, they're part of other international standards. They're part of the ITUT, the CIBEX, Cyber Security Information Exchange series. It's the 1500 series. These are actually international standards, so you can point to them, you can leverage them within your programs. Next slide, Tracy. And so our recommendations, when people say, well, what can I do about all this? We talk about the cost of poor quality, but it's like, so what do we do? One is to minimize the risks that are attributable to open source software. That's both the modules that you're using and the libraries that you're relying on, by mitigating weaknesses and vulnerabilities as well as the license conflicts. Now you have to understand that reuse is actually a software engineering best practice. The challenge is not that we're using open source software. The challenge is we're using unpatched open source software. Many developers are unaware of the fact that they're pulling from libraries that have the old versions of open source that's unpatched, and they're putting it into new products that have built-in either known vulnerabilities or certainly a number of exploitable weaknesses that are 100% discoverable. And so we want to be able to automate the detection and mitigation of open source license issues. You may have a conflict with it, and often our developers are unaware. What's the big deal about licenses? Believe me, your corporate lawyers understand this. So tools today can help you do that. You also want to be able to automate the quality throughout your workforce by using these tools that have quality domain checkers under the hood. I said security. Security is one of those, but we've got domain checkers for all other quality attributes such as reliability, performance efficiency, maintainability. Again, the CISQ standards that we've got. You want to be able to leverage many of the freely available material. I'm referencing one here. Our company puts this out. DevSecOps practices and open source software management. It helps you answer the question that, how does your organization compare to your peers? And it'll address that in terms of DevOps and the secure software development lifecycle, the adoption of DevSecOps tools, open source selection and governance, open source security and patching, open source project sustainability. There's a whole range of practices that are here freely available to you. You can download that. Next slide. And Herb actually already covered much of this, so I'm not going to go through the details here, but you really want to focus on understanding that lack of understanding of internal functionality. And too often when we bring in outside source components, such as open source, or we point to and pull from libraries, where we get DLLs that are widely used, the challenge is if you don't understand, it's very difficult to actually manage something that you can't measure, something that you don't know that you have. And one of the ways that we do that, as Herb pointed out, there's all these ways that you can go all the way from encapsulation, which is very important now with what we're trying to do, moving to the cloud, rehosting, replatforming. But we also want to be able to understand what we have. And that's why one of the best practices is actually creating a software bill of materials for all the software that's in network connected assets. And this enables more resilient response to a changing threat environment. So you want to be able to have your DevSecOps team to be able to have that bill of materials. When a new threat comes out, you want to be able to say, where am I affected? And so that really helps that overall resilience of an enterprise. Next slide. And so if you want to look at how do you focus, and the ISO standards in the 25,000 series really help us there. 25,010 on software product quality talks to the different quality characteristics, security being one of them. What we've done within CISQ is to literally generate these automated source code quality measures that are based all at the source code level so that I can use tools to detect these. They're 100% based on CWEs, and they provide this model for helping to guide what we do in process improvement, but more importantly, to automate quality and workforce using the tools with those quality domain checkers under the hood. If you can't automate this, you can't scale, and certainly you can't respond in a sufficient means. And some of the ones that we've come out with that are the more popular ones, when you look at security, these are 74 different CWEs that we focus on that include the SANS top 25 as well as the OWASP top 10. Reliability, these are on source code impacting availability, fault tolerance, and recoverability of software. Performance efficiency is very important. Maintainability also, given the long life of most software applications that we have. But hit one more button there, Tracy. The one that we just recently released was on data protection. Again, 100% based on CWEs. And you shouldn't be surprised that there's a lot of relationship between data protection and security and reliability. And what we're looking at here is within source code, those things that affect data leakage or data corruption. And specifically, these are potential vectors that could enable unauthorized reading or modification of data. If we understand just how much enterprises today are looking at privacy and data protection as issues, and we now have laws that deal with this, it's all process-based, and we said, how do you do that? But you can actually scan software that's running in your enterprise to understand, does it allow data leakage? I don't care what kind of process controls you have. If your basic enterprise assets, if they allow data leakage, that's where people are finding things. These are sources for data breaches. These are all kinds of exploitation. Next. That's why you want to be able to focus on eliminating, mitigating those. As Herb pointed out in the report, there's many practices to employ, ranging from prioritizing the needs and requirements. But there's some basics, the fundamentals that we've got to just get back to. Minimizing complexity is one of those. Using systems engineering discipline, planning for defect fixing and refactoring. And again, when we talk about these defects, we're including security defects, not just the other quality defects. And so that's why we've got to have quality gates as well as what we're doing. Bottom line message here is test all software prior to release for use. We say all, not just the software you develop, but that includes open source components that you brought in to make sure that they've been patched. You want to be able to check all the software that's running in the libraries, DLLs. You want to be able to check all of those because they change over time. You didn't necessarily change them, but your applications rely on them. And more importantly, the users of your software rely on that, and therefore they're the ones who are put at risk. It's not the development organization, it's not the project office, it's not even the acquiring organization. It's the using enterprises and the users of software that are put at risk if we don't check software prior to being released for use. Next. So it's over to you, and you can roll it out here as the lesson on this webinar.
Great. Now it's over to Dr. Bill Curtis. This is, part 3, our final part before we head into Q&A. So CISQ's role in developing standards for trustworthy software. Bill, are you on?
I'm on. Let's go.
Hey, Bill. Okay, over to you.
Okay, roll it to the next slide. CISQ was formed back in 2010 by Dr. Paul Nielsen at the Software Engineering Institute and Dr. Richard Soley, who heads the OMG. and they were both getting requests, especially OMG, for coming up with specifications for measures of various software quality attributes like security and reliability and maintainability, because system integrators were starting to see these written into their contracts. But the problem was every customer had a different definition of what they meant by security or reliability or whatever. So we came together to form CISQ to provide a consortium that could focus on creating those definitions and then put them through the OMG standardization process so they could become international standards, and some of them will go over to ISO. So we are a consortium with sponsors who sponsor our work, and you can see our sponsors here, as well as partners that we partner to jointly advertise each other's events and share materials and what have you. Next slide. So we have produced 9 specifications for automating various aspects of software, both size and quality. All of them have been approved except for data protection, which is going through the OMG standardization process now and hopefully will emerge soon as a standard. 2 of them have gone over to ISO. Our automated function point standard is now an ISO standard, 19515. And the automated source code quality measures, which incorporates reliability, security, maintainability, and performance efficiency that Joe was talking about, is now going through the final stages at ISO to get published. So it's going through their approval process. Right now it's listed as a draft international standard. Hopefully, and we believe soon, that they'll get through their approval process. It'll become a published standard. So this is how we go about the work of CISQ, is working with our sponsors to create these specifications for standards they think are important, with the requirement being that they're automatable, that they can be developed into various kinds of static analysis tools, and that ultimately we will take these, and the important ones will move over to offer to ISO. Next slide. These are the projects we're working on now. Joe's already mentioned them, so I won't really go back into them. The data protection, we're working on one for model-based software engineering to raise the quality metrics up to the level of model-based architectures and designs that have a formal modeling language behind them. The software bill of materials project, and one we're launching tomorrow on coming up with measures for DevOps and modernization environments, where we're looking at borrowing flow measures from Lean and adjusting them for use in a DevOps pipeline, as well as architectural measures that focus on issues in trying to modernize software so that you can migrate to the cloud or maintain it in containers and microservices and what have you. Next slide, Tracy. So this is our website. We encourage you to go there. Anyone can become a member of CISQ. Membership is individual because the organization is supported by sponsors. So the sponsors support the consortium. We have close to 4,000 members now. You can see the companies that are some of the companies that a lot of these 4,000 people come from. So it's a Fortune 2000, a collection of folks plus people from very small companies. But the objective is to really provide a go-to place for information on structural quality of software and on structural quality analysis for both size and for the various quality characteristics. So you can go push the membership button. We'll ask you some questions. Tracy will send you a password, and you're a member. And inside the website, there's all of our standards, some guidelines on how to use them, some language for adopting them into contracts, as well as presentations from all of our various cybersecurity summits. We hold those every year in Washington, D.C., and we've held 2 in Europe and 1 in India. So we'll be holding those in the future, both in India and Europe, as well as in the Washington, D.C. area. But the goal there is to bring together senior people from government and industry to talk about the steps they're taking to improve the cybersecurity, the quality of the software they're delivering, and to do a better job of measuring it. So we encourage you to become members of CISQ, to sign our Trustworthy Systems Manifesto, and to take advantage of all the material that we have on the CISQ website. So that's what the consortium does. That's how it works. You've seen some of the outcomes of CISQ work today. Herb has used CISQ as a way to promulgate some data on the cost of poor software quality in the U.S. It has become a very popular report over the last several years. So this is the objective of CISQ, is to get this kind of information and standards out and available to the larger IT community and systems development community. So Tracy, I'll turn it back to you for Q&A.
Thanks, Bill. It's exactly 2:45 my time Eastern, so it's 15 minutes for Q&A. That's amazing, right on schedule. And we do have some questions in, and Herb's been all over them in the little questions box, answering a bunch. But we've got some ones coming in that he hasn't had a chance to look at just yet, so I'll feed him to it. But feel free, now's a great time. Ooh, here's a long one. Okay.
Yeah, I was just reading that one, Tracy.
Oh, you want to read it out loud, or would you like me to do the honors?
Well, yeah, you're controlling the Q&A.
Okay. Your report focuses inwards into software development. Herb recommends to start with C-suite awareness and support for improvement. C-suite, however, is hardly incentivized to pay attention to software quality, however. Given software growth and increasing dependency, C-suite's learning curve will likely take too long, and the market will not be able to respond fast enough since demand too lags due to invisibility. What is your view on focusing outwards, i.e. introducing incentives to the C-suite through policy intervention, through product liability, or generally a general software quality regulation akin to GDPR?
Herb, I know you can answer for that, but I also have a perspective on that, because
Please go first.
People don't care about software until all of a sudden they do. When you see news articles that say major breach, all of a sudden they want to know why. How did that happen? And when it traces down to software, then people are going to say, go fix it. That's been one of the challenges. If you don't ask for it, if management doesn't ask, how are we doing, then why would you expect your development teams to do that? And quite frankly, I think is what we need is better informed customers who are demanding this of that, customers who are doing as part of their acceptance testing that says, before I take your software that you've delivered to me and put it into my enterprise, we want to test it. And we're checking it against these standards that we've just been addressing here in this webinar. That's where we can start changing it, because enterprises will respond to their customers. If we have customers demanding it, don't taking an attitude of saying, oh, it's software, I'm a victim, I can't do anything about it. Absolutely, you can do something about it. And that's why if we start having that conversation between customers and suppliers, and when customers are asking for it, because I will tell you, some people have been arguing that says, oh, security costs too much. But you know what? It costs nothing by comparison to what it costs by not doing security. And people have to understand that model is reversed. It actually, we save money by investing in security up front.
And generally in quality.
Yes, yeah, which is the old adage, quality is free. Well, it turns out security is too, if you focus on it up front. Absolutely.
So in my answer to Mr. Toeit's, I guess it's Toeit, to his question, I spent a good deal of my 50 years of consulting time teaching C-suite executives the right questions that they need to be asking to change the culture of their organization to be focused on quality initially rather than after the fact. And I would guarantee you that right now, the C-suite executives at SolarWinds are really interested in this topic and aware. Okay, it's unfortunate that they had to wait until a major breach to test out the fact that their software had vulnerabilities in there. So I think that C-suite executives are easily motivated by just watching what's happening around them. If they're taught to ask the right questions, I don't know that we need these kinds of regulations that you're referring to. I don't know that they're bad, but we don't have much experience yet.
And this is Tracy. I'll just recommend as a resource, it's up here on the slide as well, the Trustworthy Systems Manifesto that we developed. There's 5 policy principles in this document. It's really well thought out, and it's targeted at executives who now own this risk, software risk. And, most times they're not software engineers, software developers. So these policy principles, map back to questions that the executive should be asking of their teams and what to look at. So take a look at that. It's up on our website under resources, the manifesto. Okay, next question. My connection dropped at the start of the webinar when you stated how you measure, estimate the cost. Can you restate how you measured, estimated? I'll send that over to you, Herb.
Okay. Can I?
Your favorite?
Can I restate how I did? Okay. I guess this person missed that particular slide on the methodology. But as I said there, basically what I did was I went in using the assumption that organizations are not measuring this stuff today, so you can't ask them directly. So I had to rely on some 88 sources of available information and studies that are all hyperlinked in the report that you can go see yourself because they're all available to you. And from that basic data, I had to make some assumptions and some extrapolations in order to come up with my estimates. It's not the kind of rigorous empirical study that I used to do back in the 80s, but it is what it is in order to come up with a first order approximation of how big this number is. So, and this is described in the report. And if you have more questions about that, let me know.
And your slides are available as well.
Sure. Let's move on to Steve Taki's response because he put some interesting data in his response. I hope everybody can see it.
If they can, I'll take a quick read. He says, FYI, I have data from 5 different software organizations involving many hundreds of developers that shows an average of 61% of the labor hours on software projects are spent fixing defects after the developers claim the software worked. Clearly, that leaves only the other 39% of the time for all development and enhancement. The cost of poor software quality is the single largest, and it's more than all other costs combined.
Absolutely.
Yeah, I'll just point out to you that that comment comes from Steve Taki, who is a well-respected source of knowledge in the software engineering and quality field, and I appreciate those comments. I've seen similar data in the organizations that I've worked with, and I thank him for adding to our webinar. Thank you, Steve.
Next question. I see as the move to DevSecOps has grown, project managers and engineers believe that quality is built in. Is there any data in your research to support or counter that position?
I'll give you my perspective on that, is that most organizations have been, to some extent, looking at quality. And they often organize so that the development team and the QA team and even tests is all about quality. And you have a separate security team, even though, as we've said, security should be part of it. We can enable them to become part of it. I will tell you, because of all the breaches that you've been hearing about and all the exploitation of software around security issues, that's why there's more focus now on security. It's never to say we haven't been doing quality, but it's much more, that one aspect of quality, security has gotten much more attention. And we have to help people understand how we can help it at the software level, help them focus on security and not have to do all these workarounds that says, well, it's software, it's going to be exploited. We can actually do something to harden the attack surface.
Thanks, Joe. We have a few more minutes, plenty of questions, which is great. That's what we like. Right? Our cybersecurity insurance policies and their premiums indicating the extent of the problem and perhaps driving a new demand function for being more proactive by chance?
Again, I'll share my perspective on that, but you have to understand that any insurance, cyber insurance included, it's based, your premiums are going to be based on somebody's perception of what is your residual risk exposure. When it comes to software assets that enable enterprise capabilities, we're gaining a much deeper and broader understanding of residual risk exposure associated and attributable to software. And that's where you're going to start seeing changes in that. And there's other nuances of cyber insurance that I'm not going to get into, but again, it should be based on an understanding of residual risk exposure, and a lot of that's based on what drives your capabilities.
Thank you. And the next question here, I think, goes back. I was mentioning on our site the Trustworthy Systems Manifesto, which is good for the C-suite. So if you go on our website, because the question is, where can I find that? If you go to our website, which is it-cisc.org, there's a resources tab up top in the navigation bar. So click that, and it's the Trustworthy Systems Manifesto. And the next question is, do you see improvements in areas such as alpha and beta testing for ensuring customer satisfaction? They have been around for a while, but we still see the need for improving customer satisfaction. Hence this question, do you think it is not done right at the moment? Or not done right at the moment?
Yeah, I think the majority.
Well, I think that's actually a question in response to an answer that I gave to to this attendee back a little, back a few messages ago. So I don't know if everybody online, has that context, but he was asking me initially about, what are the ways to ensure customer satisfaction earlier in the development cycle? And I had suggested, using typical user customer representatives for alpha and beta testing, was a technique which is, popular. But, on the other hand, getting the customer involved early on in the development cycle to establish the correct requirements is probably a good idea as well. So, customer satisfaction is based on customer expectations, and you can set expectations high or you can set expectations low by involving the customer, our representatives of the customer, our surrogates of the customer, as early in the life cycle as you can, which is essentially what shift left quality is all about. So
and that's also been that's what agile development's been about as well, making sure that you've got an actively engaged customer rep, and that assumes that customer rep actually knows what they want. A lot of times it comes down to, well, once they see something, then they know what they don't want, and they say, oh, aha, now I know this other thing. So a lot of times that's why it's iterative, but that's the growth of agile has represented the involvement of a customer.
Thank you, guys. So we're coming up at the top of the hour. I think we'll sneak in one more. This is more of a comment, another piece of data to share. And everyone else, the questions we haven't gotten to, there's just a couple. We can email you a reply. So here's a piece of data to share with our friend Colin. We just analyzed 860 user stories from a development house on a commercial system and found that all 860 had at least one significant defect This is not atypical of what we see. Accenture also noted that 35% of production defects they see are coming from requirements. So just a little tidbit.
But that's actually a good reality statement there. If it's a defect in requirement, it doesn't matter how you code something. If it's a defect in architecture, it doesn't matter how you code. So you've got to get those parts right. And the challenge is that defects, if you release software, if you put it out there, that is technical debt, because eventually you're going to have to fix it. And it just, as we all know, it gets more expensive the further you go down that life cycle.
And I'd just like to throw in my thanks to Colin for that question. Appreciate it.
Great. Any closing thoughts before I send us on our way?
Let me throw in one very disturbing observation, and that's that you see a lot of questionnaire survey type things going out now, and when they analyze the responses, something like on average 40% of the respondents claim they were self-taught in the language they're using to write programs. That's scary.
Yeah.
Because that means they've got no background in security and architecture and a lot of other things, or they went to a 90-day boot camp, which is just as scary because they don't have time to teach good software engineering. So this is a trend that's dangerous, and things won't get better until we require the industry to get better.
And there are some requirements now for software engineering if you're going to claim to be a software engineer. Right, Herb?
Oh yeah. Oh yeah. There's a body of
Texas
knowledge.
has a license.
Ethics. There's all sorts of good stuff.
Yeah, Texas requires that if you're going to claim that you're a software engineer, you have to get licensed. You can be a programmer, that's fine, but if you want to claim you have to use the engineer word, you've got to go through state licensure. It's not a bad trend.
Right.
Agreed.
The point
Tracy,
is,
back to you.
Yeah, we shouldn't be taking the attitude that we're all victims. We can actually do something about that. We understand it is a challenge, but it is doable. There are actually positive things that we can do to be preventative so that we're not continuing to contribute to this huge cost of poor software quality.
Thank you, guys. I'm going to be sending an email around to everyone that signed up for the webinar today, so you have our quick links, and if you'd like to continue the conversation, I'll also share, Bill mentioned the projects that we're working on in the standard space. We're looking for organizations that might want to sponsor our new project on architecture and flow measures for DevOps modernization starting this month. But thank you for tuning in, and thank you, Herb, Joe, and Bill for presenting today. We look forward to seeing everyone again soon. Have a great rest of the day.
Thanks.
Bye-bye.
Bye.
Bye.